the strongest acid is on the left, so it forces it to the right. So if you produce H3O plus, it means you're dealing with equilibrium of an acid. So identify the conjugate acid-base partners of these species. I haven't, again, put the subscripts in to keep it tidier. The H2O, of course, is the only one that's a liquid. So identify your conjugate acid-base partners, and we're going to do the same thing, write out a K expression. Ask yourself, who lost the H on the left-hand side? The one that gave up the H is your acid. The one that accepted the H is the base. Evan? Yep.
So A is your base, H2O is your acid. And your HA is your conjugate acid, while your OH is your base.
Beautiful. Thank you. If we produce OH minus, that means our equilibrium is for a base. The strongest base is on the left-hand side. It's proceeding to the right. So your K in this case will be a KB. So write out your KB expression. Evan?
I put OH negative on top with HA. On the bottom I had A minus.
Good. How are these two equations similar? How is the top half similar to the bottom half there? Edmund?
They both have products over reactants.
They both have products over reactants, but what can you tell me about the species that are included here? Yeah? The HA and the HA and the A minus. So what you have here is an equation for an acid and then followed by its conjugate base reaction. So these two reactions are similar because one is the reaction of a weak acid. The second one is the reaction of its conjugate base. Yeah?
If it's the reaction of a weak acid, does that mean the conjugate reaction is for a strong base? Because like on the form, on the sheet you got, it said like the weaker the acid, the stronger the
The
base.
weaker the acid, the stronger the conjugate base. So I'm going to show you today how you figure out what the actual values are. If you only have in a table a Ka or a Kb, you can find the other part. So if you're given an HA and you're given its value for Ka, you can find the Kb for its conjugate base. And this is where math is going to come in. So we know H3O plus times OH minus is equal to 1 times 10 to the negative 14. we know this. We can find, we did this a while ago, we can find the hydronium or the hydroxide ion if we know the other. So we can find pH, pOH, whether our solution is acidic or basic. Are you with me so far? We know this relationship. So pH, if you take the log of this equation, you end up with pH plus pOH equals 14. We've already used that equation too. We did that before the break. Now, what I want you to do is rearrange your Ka and your Kb so that you've got H3O plus isolated and OH minus isolated. So you should have something like that, what's written in green. Yeah? Now plug those in to this bottom equation right here. Plug those values in. What are you left with? Plus water will make ammonium and the hydroxide ion. And that is because nitrogen has this lone pair of electrons that can accept an H+, a hydrogen with no other electrons. So you make a coordinate covalent bond, you don't know which one it is. But that's basically what happens. The equilibrium constant, or base ionization constant, is written as Kb. So in this case, your Kb would be your conjugate acid times OH minus all over your weak base. So that is the same as it's been for your Kas. So hydrazine N2H4 plus H2O. It's a weak base, so it accepts an H+, so it's always going to be the same formula, except one more H and a plus charge. Because the water lost an H+, you're left with OH minus. Bless you. What is the pH of a 0.1 molar solution? You need an ice table. Because your ice table is the one that goes into your K expression, if we solve for X, we're going to find our hydroxide ion concentration. So, set up a KB. Bless you. N2H5 plus, OH minus, over N2H4 it gives you a KB value, so you substitute that in. Now you're going to solve for X. Your KB is pretty small, so you can solve for your quadratic equation, or assume 0.1 minus X is approximately 0.1. 10 to the negative 6. Solve for X. Okay, either way, you're going to get the pH. Oh, sorry, it's 10 to the negative 4. So figure out which way you like best and stick to it. Your KB, because you produce hydroxides, should be your hydroxide times the conjugate acid all over the base. So you would have acetic acid on the top and the acetate ion on the bottom. What did you find for a KB value? Is it in the table? It's not in the table. So that means you've got to go to your Ka table and find acetic acid.
Found it, did it,
Is it 1.8 times 10 to the negative 5?
Yeah, it is.
Yeah. So there's how you find your KB. Okay, so I've set the question up for you. You do the rest.